Hi everyone. In this lesson, I'm going to do a revision for chapter 1 on quadratic functions. So let's recall, in this particular lesson, what we want to take note is there are few lesson objectives that we must be very familiar with. So the outcomes, you must know how to complete the square successfully. And in this lesson also, you must be able to find the maximum or minimum value of a quadratic function. Then followed by, you must be able to state the conditions for a quadratic function that is either lie completely above or below the x-axis. There is another outcome in this particular chapter which I will not cover in this particular lesson. That is the real world application type of questions. Now let's move on to the lesson itself. So if you refer to your textbook, page 13, you will be able to see this summary page. So this will give you a good guide of what you should know for this lesson itself. So make sure that you take some time to revise them and to pick certain questions from the textbook and to revise them. So in this lesson, I will want to focus on how to explain whether a quadratic curve lie completely above or below the x-axis. This is a question that you see in your end of the year exam, question 2. So over here, you are required to know how to express this quadratic function in the form by using completing the square. So if you are able to do that, you will be able to derive y equals to -3 bracket x minus 2 bracket square minus 1. So based on this, so let us just do a quick recap of what you should already know. So beside completing the square, so the other that you need to know, if you can remember what I mentioned earlier on, that is, you must be able to know whether how you are able to find the maximum or minimum value of a quadratic function. So in this case, if you make some observation, so you will see, right, you will observe that in this case, the coefficient of the quadratic function is actually negative, it's -3. So in this respect, if I know that it is -3, so with knowledge, you will know that this will give you a maximum graph. So which means your curve, your quadratic curve it will look something like this. So when you have a quadratic graph like this, so which means what you have is you will be able to get a maximum point. All right, so whereby your maximum point, which is here over here, so whereby this will give you a maximum point. All right, so how do you find what is the maximum point over here? So given this maximum point, you will be able to see from the expression. So this itself, this will give you the x coordinates of the maximum point. In this case, your x coordinates of the maximum point will be 2. And this value itself, this -1, this will be your y value for this maximum point. So for those of you, if you are not sure how to find the maximum point or the maximum value for a quadratic function, please do go back and to revise. So over here, I'm able to see this. So in this case, I know that the maximum value of y in this case, it is actually equals to -1. Yeah, whereas the maximum point in this case, it is 2 and -1. So when we talk about point, we are referring to the coordinates. So let's move on. Once we have this, so let's move on to see how can we explain the question. So question 2b, it asks you to explain why this quadratic function lies completely below the x-axis. Now let's do a recap. On page 13, you will see these conditions here. So based on this, so if we see that the question asks you to explain why this lies completely below. So if it is lie completely below the x-axis, you will know that it is the second conditions over here, the second bullet point, which means you must be able to see that, right, the condition is simply a is less than 0. And in this case, a is actually referring to the coefficient of x squared. And not only this a less than 0, you must be able to state that the maximum value of this quadratic graph, it has to be negative. So negative is simply mean it has to be less than 0. So when you see this particular statement, you notice that there are two informations that stated here. The first condition, that is, you must state that a is less than 0, which is a coefficient of x squared. And the second important condition that it must be mentioned, it will be the maximum value has to be less than 0. So based on this condition or this information, right, if you take a look at the questions here, in this case, you will notice that the condition has been met. So you will know that in this case, yeah, a, which is a coefficient of x squared, it is less than 0. Next, you also know that the maximum value of this function here, right, it is negative 1. It is also less than 0. So with all this information, now it is time for you to write down the proof, all right, which is the explanation. So we shall put all these things together. So with this, so you're asked to explain. So which means there are two important conditions that you have to mention, right, based on this completed form. So you have, since the coefficient of x squared is equals to negative 1. So this will be your first condition, right? This is less than 0. Then the next condition that you must state, it will be that the maximum value of the function here is equals to negative 1. So with these two, then you can conclude. So over here, we are talking about using PU. So this is your link. So your link here is basically, you just need to restate the entire question that is given. That is all you need to do. All right. So at this point, I will also want to highlight one important misconception, all right, which a lot of students actually misunderstood, right? Maximum value as maximum point. So do take note, maximum value is not equals to maximum point, as I mentioned in my previous slide. So maximum point, in this case, we are referring to 2 and negative 1, whereas maximum value, it is equals to negative 1. So do take note of this important information. So with this, I conclude